Hi, I'm François-René Rideau from Sky Protocol. Today we did the first stupid thing we can do with Sky, which is decompose a string in many parts and recompose them into one part, which is a basic erasure coding functionality. So how do I do that? Well, I define polynomials over the field with 256 elements. In practice, we may use a larger field to have more participants. Like this means this field means there are 255 participants max and things like that. But we can do better. This is just an example, and this is very easy to change this parameter. And then we take a, a string hello that we explode into numbers, and we assign the numbers to coordinates. So here's how the string is then encoded into coordinates, and from these coordinates we can recover the original string using Lagrange interpolation. Hello. So it's a thing called as Reed-Solomon encoding, and that allows you. It's a very funny mathematical property, Lagrange interpolation, which means that if you have n points, you can reconstitute a polynomial of degree less than n. And so it doesn't, so you, I can give you now, instead of, uh, I can give you 100 points and make sure that uh, these 100 points are all on the same polynomial of degree less than, of degree 34, say, and therefore with, or 33, of degree 33, and therefore with 34 points, we can reconstitute these. With any 34 of those points, we can reconstitute this polynomial. So I can now divide my strings into strings of length 100 or 1000 or whatever the number is, and give you, you give me 34% of those strings back, and I will reconstitute the original strings. So that's the basic functionality. There's not much to it. It's well-known mathematics, but we're doing it the right way with lots of mathematics. The right way. The code is very clean, very nice. What does the code look like? This is a code for Lagrange interpolation using uh, generic polynomials. The thing you can see that's interesting, we use a Euclidean division of polynomials here, and that's how we do things quite efficiently and at the right level of abstraction. Say at the right level of abstraction, this code is very simple. That's what it should be. And that's what we're doing. And other fun is finite field. So here's what how you define a finite field with 256 elements, or with 264 elements, or the 256 elements. And every time we this field defined as again as a quotient of the polynomials by over or z2 by a proper polynomial, proper Conway polynomial. These all very well-known things, but it's beautiful mathematics. It has very efficient implementations, and like implemented with XRs and multiplication. Here's multiplication in multiplication in this finite field with a number of elements that is a power of 2. And we can also define the same thing with it's a power of another prime number, not 2. It also works slightly slower, and it doesn't fit exactly the data we have. So that we're not using the general purpose version, we're using the specialized version, we're filled with a number of elements that is a power of 2. So I think this is all beautiful code. This is not very readable by someone who is not familiar with in this case, the language scheme and this object system we have on top of scheme. So, but this is just defining like to add two numbers, just do a bitwise XOR to multiply by this generator. We do this little bit of magic, and to multiply in general, well, we do something more, slightly more complex. Well, it's all beautiful, it's all tested, and I like it a lot. I know what to say. So that's the very beginning of Sky. We can decompose our data now into um, 1/100th of the data and re-encode it, and there we go. The interesting part to me of upcoming of Sky protocol is how it will be a DEX for block space. That is, we want to be able to adjust the supply and the demand dynamically. Happily or unhappily, for security reasons, is, we cannot let the providers and the requesters, the users match each other. Otherwise, someone could cheat and become both sides of the of the deal, and then claim that the data has been made available where it actually has not. So there's a very interesting security thing where the Sky protocol has to buy, no, has to sell the block space as a single entity. So we must first have some kind of democratic vote within Sky protocol to decide the supply and match it to the demand. That's the interesting bit. And the part I'm not completely sure yet is what's the optimal way to set the collateral for the for the members, for the nodes. Of course, if the lower the collateral is, the more capital efficient it is, but the less secure the thing is. So, what is the optimal level of security versus capital efficiency? I have to think hard about it and consult with friends and with people who are good about the economics of it all. So that will be the interesting part, which is not there's not much coding, or whatever coding there will be about it will not be particularly interesting or difficult, but that's where the interesting part is with respect to the design of the protocol, like the fine grained design, how we're going to set those collaterals. So the coding is advancing slowly but surely, and the design is also advancing slowly but surely, and hopefully next week we'll tell you more about that.